Welcome to this expert-level training module. Today, we are focusing deeply on the critical considerations for accountability within the responsible AI framework. Welcome everyone to this expert-level training module on responsible AI, where we will specifically focus on the critical considerations for accountability in an artificial intelligence solution. As we integrate AI deeper into our enterprise ecosystems, we must recognize that these highly powerful mathematical tools require strict ethical and operational guardrails. According to the official training materials, Microsoft defines 6 core principles for responsible AI: fairness, reliability and safety, privacy and security, inclusiveness, transparency, and finally, accountability. While each pillar is fundamentally necessary for building equitable and secure applications, accountability serves as the foundational bedrock that essentially enforces all the others. Without accountability, the remaining principles are merely theoretical suggestions, rather than strictly enforced technical realities. What exactly does accountability mean in the context of an enterprise AI solution? It means recognizing that artificial intelligence, despite its autonomous capabilities and complex probabilistic nature, is ultimately a tool designed, trained, and deployed by human beings. It is a framework that explicitly rejects the notion that an algorithm can be held legally or ethically responsible for its own output. As an AI developer, data scientist, or solutions architect, you are stepping into a role that carries significant ethical weight. You must proactively design systems that trace decisions back to their origins, ensuring that when an AI agent or computer vision model makes an inference, there is a clear, auditable line of sight into exactly why that specific probabilistic inference occurred. To enforce accountability programmatically, developers must establish global logging configurations at the application's entry point. While there isn't a single accountability API, your foundational code must securely initialize telemetry clients, such as Azure Monitor, ensuring every subsequent AI interaction is captured, perfectly timestamped, and immutably associated with an authenticated user context. Take a look at the flowchart displayed on your screen. This diagram visually maps out the 6 core pillars of the responsible AI framework. Notice how accountability stands as a pillar, but functionally branches out to explicitly enforce human oversight and maintain all the necessary operational guardrails across the entire system. Moving forward, we must address the fundamental philosophy that underpins the entire principle of accountability. The official training documentation is completely unequivocal on this specific point. Ultimately, the people and the organizations that develop and distribute AI solutions are accountable for their actions. This is arguably the most important concept in modern AI engineering. When an artificial intelligence model generates harmful content, exhibits biased behavior against a protected demographic, or makes a dangerous operational decision, you absolutely cannot deflect the blame onto the machine. The machine learning model is simply a probabilistic mathematical engine executing pattern recognition based on its vast training data. It possesses no moral compass, no legal liability, and no conscious intent. Therefore, the absolute burden of responsibility rests squarely on the shoulders of the engineering teams who trained it, the data scientists who curated its datasets, and the organizational leadership that authorized its deployment into a production environment. If your AI-based loan approval application unjustly denies credit to a highly qualified applicant, it is the bank, and the bank's development team, that must answer for that failure. Embracing this human mandate fundamentally changes how we approach software development. It forces engineering teams to adopt a highly defensive, rigorous posture. We must build our applications assuming that the underlying probabilistic models will eventually fail or hallucinate. Accountability dictates that your application logic must include strict fallback mechanisms and human-in-the-loop overrides. For instance, in high-stakes automated workflows, your code should never route a low-confidence AI prediction directly to execution. Instead, the logic must catch low-probability scores and safely route the transaction to a human operator's queue for manual review. This diagram illustrates the human-in-the-loop safeguard. When the probabilistic AI model generates an inference, the system evaluates it. While high confidence yields standard output, low confidence edge cases explicitly halt automation, mandating a human operator review to ensure an accountable and safe decision execution. Knowing that people and organizations are ultimately accountable, the immediate technical question becomes, how do we systematically enforce this massive responsibility across complex enterprise environments? The Microsoft training materials provide the definitive answer, explicitly stating that it is highly important for organizations developing AI models and applications to define and apply a strict framework of governance to help ensure that they apply responsible AI principles to their work. A governance framework is not simply a written policy document stored on a corporate intranet. It is a comprehensive, operationalized system of checks, balances, and technical controls integrated directly into your software development lifecycle. Governance requires that every single phase of AI development, from the initial sourcing of training data to the final deployment of a generative AI agent, is subjected to rigorous scrutiny and peer review. For example, a robust governance framework dictates exactly who has the active authorization to approve a new foundational model for use, what specific safety metrics must be met before deployment, and exactly how the organization will handle reported bias incidents. In the context of Microsoft Foundry, this means utilizing strict role-based access control to restrict model catalog deployments, implementing network isolation for data privacy, and securely storing API keys in Azure Key Vault. By establishing and rigidly enforcing these governance frameworks, organizations transform the abstract concept of accountability into a concrete set of operational rules. Implementing governance as code often involves utilizing infrastructure as code templates, such as Bicep. Your configuration scripts must explicitly define policy assignments that enforce responsible AI guidelines. For example, your pipelines can automatically block the creation of any Foundry resource that does not have the mandatory content safety filters explicitly enabled in its configuration block. Observe the workflow for establishing governance. Organizational leadership defines the framework, which then branches into enforcing development policies and implementing technical controls. These manifest as mandatory peer reviews and role-based access control, ultimately converging to produce a truly accountable enterprise AI ecosystem. Accountability within your established governance framework must be heavily applied during the earliest phases of development, particularly during model selection and system testing. When you browse the Microsoft Foundry model catalog to select a generative AI model for your application, you are making a critical architectural decision that carries immense accountability. You absolutely cannot select a model blindly. As an accountable systems engineer, you must thoroughly review the model cards and responsible AI documentation provided by the developers of that foundational model. A model card provides transparent documentation regarding a model's capabilities, its intended use cases, and crucially, its known limitations and statistical biases. If you deploy a model into a healthcare application when its documentation explicitly forbids medical diagnostic use, your organization has completely failed the accountability test. Furthermore, accountability demands rigorous, quantitative testing. You must mathematically prove that your AI system behaves reliably and safely before it interacts with real users. This involves systematically evaluating the model using both standard natural language processing metrics like accuracy and F1 scores, as well as utilizing advanced AI-assisted evaluators to measure groundedness, coherence, and fairness across different demographics. By intentionally subjecting your models to adversarial inputs, you generate the empirical evidence required to justify deployment. An accountable organization maintains permanent records of these evaluation scorecards at all times. Programmatic accountability during testing requires integrating automated evaluation scripts into your continuous integration pipelines. Developers write Python test suites that query the AI endpoint with hundreds of curated benchmark prompts. The script then asserts that the model's safety scores remain above the governance framework's strict minimum threshold, automatically failing the build if regression occurs. This visual outlines the accountable model selection pipeline. Starting in the Foundry model catalog, engineers review model cards to identify capabilities and limitations. Only then do they select an appropriate foundation model. The model is then subjected to automated safety evaluations, which dictate the final data-driven deployment approval. To maintain true accountability after an artificial intelligence solution has been successfully deployed, the system must be completely transparent and highly traceable. Accountability is entirely impossible if the operations of your AI application remain a mysterious black box. If an AI agent generates a flawed financial report or takes an unexpected automated action, the engineering team must be able to forensically reconstruct exactly why that happened. This requires the implementation of comprehensive, immutable audit logging throughout the entire application architecture. Every single time a user interacts with the system, the application must persistently log the exact input prompt, the contextual data retrieved to augment that prompt, the specific model version used for inference, and the raw probabilistic output generated by the language model. When utilizing advanced patterns like retrieval augmented generation, commonly known as RAG, accountability means explicitly tying the model's responses back to your original source documents. Your system must be engineered to attach direct, clickable citations to the generated output, allowing users and internal auditors to manually verify the grounding data. By engineering your applications to continuously stream these highly detailed interaction logs into a secure, centralized telemetry database like Azure Monitor, you create an undeniable historical record. This extreme traceability ensures developers can rapidly identify the root cause of hallucinations and demonstrate regulatory compliance. To achieve deep traceability in code, developers implement custom telemetry middleware. Before sending a request to the Azure OpenAI API, the code generates a unique correlation ID. Both the inbound prompt payload and the outbound completion JSON, along with the correlation ID, are serialized and securely written to a logging endpoint, permanently capturing the AI's entire reasoning process. The diagram maps the RAG traceability workflow. A user prompt and identity enter the AI agent engine, which retrieves context via RAG. As it generates the model completion, two vital actions occur simultaneously. It attaches source citations for the user and securely writes all transaction data to an immutable audit log for permanent accountability. Traceability allows us to investigate operational issues after the fact, but accountability also strictly demands that we proactively prevent harm from occurring in the first place. An accountable AI architecture actively intercepts and neutralizes risks before they ever reach the end user. This is achieved by enforcing strict programmatic guardrails, most notably through the mandatory implementation of robust content safety filters. Because generative AI models mathematically reflect the vast and sometimes problematic datasets they were originally trained on, they can occasionally produce outputs that violate organizational policies. Accountable developers fully anticipate this fallibility and deploy automated filtering systems that sit directly between the language model and the user interface. These sophisticated filters actively scan both the user's incoming prompts and the model's outgoing completions for hate speech, profanity, violence, and self-harm references. If a safety violation is detected, the layer immediately blocks the transaction. Furthermore, accountability in applications interacting with the physical world, such as computer vision systems driving robotics, requires the strict enforcement of confidence thresholds. The application code must be explicitly designed to completely ignore AI predictions if the model's mathematical certainty falls below a highly conservative percentage, safely halting the automated process. By architecting these aggressive safety layers, organizations actively prove their commitment to ultimate accountability. Enforcing content safety in your application code involves handling exceptions generated by the AI services filter layers. If the endpoint rejects a prompt due to a policy violation, it returns an HTTP error. Your logic must explicitly intercept this error code, log the safety violation for internal review, and safely return a polite, predefined rejection message to the user. Here we see the dual-layer safety enforcement model. The raw AI output first hits a content safety filter. If a violation is detected, the transaction is blocked and logged. If safe, it moves to a confidence score check. If the probability falls below 95%, automation is halted. Otherwise, it proceeds to execute the safe application workflow. As we conclude this intensive deep dive into the principle of accountability, we must heavily emphasize that responsible AI is never a finished state. It is an ongoing, continuous operational commitment. Deploying an accountable artificial intelligence solution means implementing continuous monitoring in your live production environments. Over time, models can experience data drift, and user interaction patterns can evolve unpredictably. Accountable organizations continuously analyze their production telemetry to proactively detect degradations in fairness, accuracy, or safety. When anomalies arise, engineering teams must actively retrain their models or refine their system prompts to address these emerging challenges head-on. Accountability is the overarching operational mechanism that ensures the entire responsible AI framework encompassing fairness, reliability, privacy, inclusiveness, and transparency is actively upheld every single day your software is running. We hope this comprehensive technical session has empowered you to design and govern your AI architectures with unshakable ethical rigor. If you found this expert-level training valuable, please be sure to like this video and subscribe to our channel. Furthermore, to truly accelerate your career and master these advanced cloud concepts, I highly invite you to visit quicktechie.com for our premium certification prep materials. At QuickTechie, we offer extensive Q&A banks, ebooks, audiobooks, training, and interview guides designed to make you an industry leader. Build securely, govern strictly, and always remain accountable for your AI. Continuous monitoring requires writing automated alerting logic. Your operations codebase should routinely query your telemetry databases, calculating average error rates, latency metrics, and safety filter trigger frequencies. If these metrics breach the acceptable baselines defined by your governance framework, the code automatically dispatches high-priority alerts to the incident management system for rapid remediation. Our final flowchart visualizes the continuous monitoring loop. The live AI application feeds continuous production telemetry to an analysis engine. If anomalies are detected regarding drift or bias, it triggers engineering alerts, forcing teams to refine prompts and retrain models. This constant iteration loop guarantees we maintain accountable operations indefinitely.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by QuickTechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material. So this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this and all the the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper. It would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now, the third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepared for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechit.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.